Hello everyone, welcome back to day 38 of Coding Every Day. Today is a Saturday. I'm getting started a little late here as you could see, but at least I made it. So yesterday I completed all the medium graph problems. Probably I'm going to revisit them and just do them again so I can kind of get more used to just implementing standard traversals and cycle checks in more efficient ways. So I guess now I will be moving on to dynamic programming and greedy questions. So today, so I can look at any of these three. So I think I'm gonna look at palindromic, I don't know how you say it, substrings. And then what was the other one? Longest palindromic substring. Okay, I'll just do this one. So this is a problem. I'm not going into this one blind. This is a problem I've seen before. I've never coded it or solved it though, but I kind of know the general approach. Okay, so the problem, all right, we'll do this one. So the problem is, given a string S, return the number of substrings that are palindromes. A palindrome is a string that reads the same forward and backward. So for instance, test case 1, we have A, B, C. So in this case, all the substrings of A, B, C are, so the brute force way of kind of doing this is dividing it into all substrings. So all the substrings are right here, I believe, and then also empty string. So of these substrings, there are 3 that are palindromes that are spelled the same forward and backwards. So the brute force would be generate all substrings, which was a previous backtracking problem. And then you can just calculate the number that are palindromes. And then if we look at AAA, so all the substrings are A, so like the first A, second A, third A, and then AA, the first 2 A's, AA, the last 2 A's, and then AAA. So here the answer should be 6 if we count all of those. 6, yeah. Okay, so the way that you kind of can do this without brute forcing is you can realize properties of palindromes. So for instance, if we look at this A, it's a palindrome. Actually, so let's consider a famous palindrome, race car. Okay, so that's a very famous one. So it's spelled forwards and backwards the same way, race car. So it's forwards and backwards the same way. So if we consider this whole thing as a palindrome, by definition of a palindrome, we know that this string right here also has to be a palindrome, and this string also has to be a palindrome, and this string also has to be a palindrome. So we know that if we detect a palindrome, everything in the middle of it also has to be a palindrome. So in other words, if we think about that in reverse, and let's say we start with E as a palindrome, we know that if this character and this character is the same, the whole string is a palindrome, and we only had to check 2 characters. And then we can go up one more, and we know this string is a palindrome because the middle is a palindrome, so we only have to check the 2 characters. Okay. So basically, the strategy is, and let me make sure I'm not muted, okay. So the strategy is, you have a palindrome, you go through every letter, and if that letter is a palindrome, you check both sides by 1. And if they're the same and they're both in bounds, you increase like palindrome count by 1. So in this case, R is a palindrome, but then left is out of bounds, so then we move to A. A is a palindrome. So we check both. R does not equal C, so we keep going. C is a palindrome, but A and C are not equal. E is a palindrome, and now this is where it gets interesting because C and C is a palindrome, so that's another palindrome count right there. That's substring CEC. And then we go again, AA and RR, so that would give us the algorithm. And then you just have to do the same thing with, so for instance, if you have the word noon, this is also a palindrome, but as you could see, if we did the same logic here and looked out, and then here and looked out, we would never get the actual string itself, so we have to also do it with a window of size 2 to start. So you do one pass through with a window of size 1, and then another pass through of window size 2, and then you just go out from there. Okay, so so that's my theoretical understanding of this problem. So let me see if I can implement it. So first, okay, so let's say for I in range length of S. Okay, so LR, so we're gonna have 2 pointers, right? L and R. So they both equal I. I think the syntax, you can actually just say this. Okay, so they're both gonna equal I. And then we'll say while L is less than or equal to 0 and R is less than length of S, so while they're in bounds, and S of L equals S of R, then palindrome, so I'll just call it count, goes up by 1. So we'll just have count at the top here. So this is just our final answer. So yeah, in this case, they're the same. And then our L pointer will go to the left one, and our right pointer will go to the right one. So we'll say L minus equals 1 and R plus equals 1, like that. Yeah, so that'll work for ones, I think. So let me just print count here, make sure that's working. And let me just return 0 for now. Okay, so here my output is 1. So it should be 3, so it should look at A. So, okay. So it gets initialized to 0. And these are both true. R is less than, greater than or equal to 0. There we go. That was the bug. 3. Yeah, so it was just only running once because I said less than or equal to 0. Okay, so 3, that looks right. And then for this one, my answer is 4. Okay, that's because it's missing the palindromes of even length. So for instance, what's going on right now is, so I is here, and then L gets out of bounds. So this letter only gets 1 when I is 0, and then I is 1. So we get this palindrome, and then we get an additional palindrome here, and then they go out of bounds. So that's 3, and then when we check here, we get 1 more. So that's 4. Okay, so this loop seems to be working. So we can do the same thing, except we're going to initialize L to be equal to R plus 1. So we can just make this a function. palindrome check, which will take in L and R. I'm trying to think what the parameters would be. And then here we would just so our other loop, right, would be for I in range length of S, and we would just say L equals I and R equals L plus 1, or I guess I plus 1. Yeah, like this. So this could just take, I could make this variable a parameter and have it be 0 or 1. Let me, Also, I could call it like recursively and have it update I every time. Or could I just, for I in range length of S, could I call the function both times? Palindrome check of I, and then I guess I could do this, I plus 1. Then we have LR like this. Okay, I'll try this. And then if I return count, am I muted? No, okay. All right, let's try this. So it's trying to update count. Okay, let's do it like this then. So we'll make count a local variable, and it will return count. And we'll say count plus equals this plus this. And here we'll say, so here this is the global count and the local count, like that. All right, there we go. Okay, so I believe this is considered dynamic programming because of the palindrome property I was talking about, where you know that if you have a palindrome like race car, that all of its inside, like it's all substrings within that palindrome are also palindromes. So you can use that property to, instead of rechecking, like for instance, let's say we're at CEC. Instead of rechecking, like, and we go out by 1 to ACECA, instead of rechecking all of the middle, we can just check these two characters, because we can assume that the middle is already a palindrome because of the properties of palindromes. Yes, so that's this question. And then for this one, longest palindromic substring, I wonder if you could just do the very, like, the same thing as this, except just have a max. I could try it quickly. So instead of count plus equals, you would just say max length equals max. Okay, yeah, so let's just do this one, because that one was only 15 minutes, so we'll do this one in this episode too. So, okay, and we can return any one of them. So this problem, longest palindromic substring, given a string S, return the longest substring of S that is a palindrome. So let me start from scratch again. A palindrome is a string that reads the same forward and backward. Okay, so I'm thinking we can find the max odd length and then the max even length. So we'll say for I in range length S, and then we'll say left R equals I. Okay. And then same thing. So while left is greater than or equal to 0 and right is less than length of S, and S of L equals S of R. And I know I just wrote this, but I think writing it again just helps kind of reinforce the ideas. Okay, so here we'll say counts plus equals 1, L minus equals 1, R plus equals 1. Okay, so when do we want to check the max? I guess every time, so we could have a variable called like max length. And then every time we increase count, we can say max length equals max of itself and count. So would we have to reset? I think we'd have to reset count equals 0 every time here. Or I guess count equals 1. Yeah, so we reset it to 1 here because we count the string that we're on, so like B, and then if this is true, well actually count should go up by 2 because we got to include L and R like that. Okay, so if I return max length here, this will work for even palindromes, I believe. My output was 5. Oh, I have to return the string itself. Okay. So we'll say here if count is greater than max length, then max length equals count, and I'll just say max palindrome equals, and we'll just do pointers. So I'll just say max. Okay, so yeah, so we'll just store the pointers like that, and then at the end we'll just return L to R plus 1 like this. Okay, so I answered BD. No, okay, I don't actually want that. So we say LR equals max pal. Okay, I returned empty string. Okay, so let me see what. Let me print here max length L and R and see if that's correct. Okay, so it's telling me 5. That doesn't seem right. That does not seem right. -1 and 3. Okay, so I'm thinking here if we have A, B right here. Okay, so these all get set to 0 and count is 1, this A right here. So while it's in bounds, okay, so maybe here count is actually supposed to be 0. So it has to increase by 1 at the start. Okay. So I see the error. So I had this at 1, and then it's getting increased by 2, so the max length is getting counted as 3 here. So what if I initialize it to -1? And then the first one will make it 1. Like that. So my idea here is that if I initialize it to -1, the first time it happens, the only time that it should only go up by 1, it will result to 1. And then every subsequent time, it'll just go up by 2. So it'll be 1, 3, etc. So this is all correct. So L is going to go -1. So counts will be, and let me just print here, max updated, and then I'll print max length and max pal. Max length and max pal, like so, just so I could see if this is working properly. So we'll run this. Still not muted. Okay, good. Okay, so length is 1, and then, and also too, I just want to see what I is at this point in the program as well. Okay, so when I is 0, it updates max length to 1. So y is L -1. Oh. Okay, so we actually want to do all this stuff first before we change L and R, like so. Okay, so length of 3, starting at 0, 1, 2. Okay, perfect. Okay, case 2 is even. So how could we adjust it? All right, so now this is a little bit more tricky because in this case, all right, so let me just write another for loop, and then we can see if we can condense the code. So in this case, so for I in range length of S, so this is checks odd length, and then this will check even length. So before I try to optimize, it's something I'm working on. Before I optimize, just write something that works. Okay. So now we're going to check even length here. So we'll initialize L to be I and then R to be I plus 1. Okay, and then counts at this stage will be 0 instead of -1. And then we'll copy this part and count will go up by 2. Counts plus equals 2. And then I think all that is fine. Okay, let's see if it works. Okay, it works. All right, so now it's correct. So what are the differences between this function? So there's a 1 here and a -1 here. So we could have a variable right here called like, so this could be equal to I plus is even, and then this could be -1 plus is even, where is even is either a 0 or 1. And that would work. So I think I'm going to do that. And that's totally fine. Okay. So let's make a, now the only thing is, okay, this will be interesting. So if I say get max palindrome, and it will take in L and R and is even, okay? And then we will say L equals I. No, we already know it. Okay, so R plus equals is even, right? Yeah, so if it's even, it'll go up by 1. And then we say counts equals -1 plus is even. All right, and then we do this part like this. So if it's even, R will get set plus equals 1, and then this will get set to 0 if it's even. And then counts here. Okay. So at the end of this, we should return. Okay, so now my problem is, all right, so if we comment this out for a second. So the way I want to do it is for I in range length of s like this, right? Still not muted, okay. And then I want to call get max palindrome of I 0 and get max palindrome of I plus 1, 1. So that's what I'm thinking. So what do we need? We need to figure out the max of these two. So this should probably return. All right. So max length equals 0. And then for each one of these, we can check. So if this is greater than, okay, and this will be a tuple. So this will return a tuple of max length and max pal. And then so we could say if the max length, so if this is greater than max length, then max length equals whatever it returned. Okay, so I wonder if there's a better way to do this. I could do it this way. Okay, let me do it this way, and then we can optimize from there. So we'll say odd results equals this. Okay, so if odd results, then we could say even results equals this. And then if even result of 0 is greater than max length, then max length equals odd res of 0, even res of 0, and then LR equals odd res of 1. So these are the pointers, and then here LR even res of 1. Max length. Do we just return the length of the palindrome, I guess? We don't really need to do this anymore. Max pal. Okay, so we could just return L. We could return L plus 1 and R minus 1 just to undo this change, I guess. Okay, maybe I should stop pressing submit. Okay, so this one worked. This one did not. All right, let me print here. I can print I, and then odd res. Like that. Okay, so this one works. So let's look at this one. Test case 2. So when I equals 0, even should be, even gives me 1. Oh, those are the pointers. So these, it's giving me the same pointers for even, which is not good because even, I'm passing it 1, right? Is even. So R should be 1 ahead of L. Is it this part? I thought that this would just undo the last change. Okay, let me see what happens when I print L equals R equals. So let me see if the pointers look correct at this stage in the program. Okay, so, oh, I don't need this part of the code actually, because I'm already passing in +1 here. So this part doesn't need to be in the code. Is that the only thing? Yes, okay. So let's see. Let's think if there's a better way to do it, if we can optimize further. Okay, so this is the current. This is the current solution. Okay, so I'm thinking I don't need this is even parameter because what I could say, we could just always add 1 to the count. Does this work? Okay, so I'm going to get rid of this. Just because I think it's a little clunky to have that. Even. Okay. Okay, so count is going to be equal to -1. Okay, so does this still work? Yep, okay. And now the last thing I feel like is a little clunky about the program is this part. Can I just deduce the... I think I can deduce L and R. Just this part returning the... I think if we just return the count and we know I, we can actually just determine the length. So let's say our string is like this. And let's say we know I equals 2 and the length equals 3. That's not possible. Let's say 2. So if I equals 2 and the length equals 2, then we know it's like this. Okay, let's think about just even, or sorry, odd for now. So if it's 2, then you can define that as, so it's 3. How do we get 3? Mod, or integer division 2 is 1, and then you plus or minus 1. If you have 4 mod 2, you can plus or minus 2. If the length is 5, 5 mod 2 is 2. 1, 2. Okay. So for at least for odd, you say that LR equals I minus count divided by 2 and I plus count. So this is how you get L and R for here. If the count is even, then you just do a +1 to R. So for instance, if it's 2, 2, so if this is 2, then you do 2. Is it -1? So you do left is like count div 2 -1. So in this case, if the length is 2, then this should be 0. And if the length is 2 on the right, it should be 1. Okay, so I'm just going to write that down before I forget it. So you would say here that LR equals I minus count -1. And then like that. Let me test that formula here. Okay, so if we have this, let's say I equals 2 and count equals 2. So according to my formula, L should be equal to I minus count div 2 -1. Okay, so let's evaluate that. So it's 2 minus 1 minus 1. This evaluates to 2. And then, okay, I think that's correct. So let's use this method instead. And instead of count, we should use max length. Okay, so let's see if this works. No. I know it does work, so I don't know. Is it this part? Well, this does give us the max length, right? And do I need to do this at every iteration? I don't think so, right? I don't think this will fix my bug, but okay. So this fixes it. This fixes it. Okay, so my output for this one is blank. All right, so let's see. So why is L? In this case, L is greater than. All right, instead, let's put LR here. See what that equals. Okay, so here it's updated, so LR is 0, 0. Then at I equals 1, we get 3, so L is 0 and I is 2. That's correct. Here the count is -1. Okay, that's a problem. This should not be returning -1. Why is that? I guess that. Why is that returning? That should never return -1, right? So if we're even. Oh, it returns -1. Oh, actually, yeah, a -1 is good. But I wonder if that causes a problem with my. No, because it's not greater than. Okay. odd of 0, 1, 2, 3. No, odd of 0, 1 is 3, 0, 2, that looks good. Okay, so that one's good. So let's see where this one messes up. So odd returns length of 1, 0, 0. Even returns not possible. I equals 1. This returns odd of 1, 1. That looks good. It doesn't update the max though. Even, so even at I equals 1 should be a count of 2. Yeah, it is technically. And then L equals negative 1. Okay, so this must be the problem. L equals negative 1. This is the problem here. So here it should be L equals 1 and R equals 2. So here the length is actually 2. So max length equals 2. Okay, so is it a order of operations thing? I don't think so. Okay, so let me at the start of my program print these two values right here. Let's say max length equals 2. And let's see. And I equals 1, right? That shouldn't make a difference, right? Why is that? Okay, so I'm just messing up my arithmetic, I guess. 2 div 2 should it be 0 and plus 1? So 2 div 2 is 1. 1 minus 1, yeah, so that is negative 1. So did I make a mistake? Maybe? 0, 2. Oh, do I not have I plus? Oh. Okay. Alright. Let me see the mistake again. So it's L negative 1. So this should not be there. Wait, what? So it should be I. Okay. I just have to do the arithmetic here. So I. What is it now? Wrong test. No, right test case. Okay, so it's saying 0, 2 now. So when I equals 1, it should be 1, 2. No way I add 1 to this. And that just is like the general case, right? Okay. Alright, so we don't need this then. So we can return count. And get rid of all that. Don't need this. Don't need this. So the only difference here is here I'm adding 1, and here I'm not. All right. Can I say if max of get max? Well, so the only reason I can't say this, max palindrome, well maybe I can, palindrome of I plus 1 is greater than max length. Max length equals, well I need to get the result of this. So like, check, all right, so I could say this, so if count is greater than max length, then max length equals count. Oh, and now I can say, actually, I don't think I need to do it every time either. Hold on, let me undo this. I have an idea. First, let me check. Okay, this solution works as is, right? Okay. Let me check if this still gets me the answer or not. Really? Okay. I thought I would only have to calculate it at the end. I have to do it every time? Why? Oh, because it could give me this one. Alright, so before, what was I thinking? So count equals max of get max palindrome of I and get max palindrome of I and I plus 1. Okay, if count is greater than max length, then max length equals counts. Okay, and then my idea was we can say if counts, actually there's a slight problem with this. That being this part here, I was adding 1 to the even result. I guess I could say if L does not equal R, okay, so if L does not equal R, so in other words, if, well, I guess we want it like that. Okay, so if they're equal, then count will start as -1, otherwise 0. Okay. If counts is even, then we'll say this one, else oh wait. Maybe I can use that property. So plus 1 minus count mod 2. So if this is 0, then we want the 1 there. Then let me just comment this out. Does that work? No way. Nice. All right. Okay, so basically what I'm doing is just using instead of like doing if statements, if it's even or odd, you can use the modulus property in the arithmetic like this. Okay, is there any other ways I could optimize this? This part is a little unintuitive, to be honest. I think everything else kind of makes sense. But yeah, so okay. So I'll just keep it like this and leave the episode there for now. So today was day 38, I believe. We got 2 problems in today, so thank you very much for joining me, and I'll see you guys tomorrow for day 39.